Hi friends. So we are covering the infrastructure as a code. That means Terraform. So right now we are seeing the fundamentals. Before we move into Terraform, we are covering the infrastructure as a code fundamentals. What is ISE? How it is used? What is a resource life cycle? These are the basic things we need to understand before we move into Terraform. So for the last past two videos, we covers what is infrastructure as a code ISE. What are the types of ISA tools available? In this video, we are going to cover the basics only. In large scale enterprise, most of the MNC companies, they are managing their client infrastructure by using ISA tools only. So we should learn and practice these ISA tools if you want to try jobs in MNC companies. As we know, infrastructure as a code ISE is a process of defining and managing the IT infrastructure through code. So we create the Terraform modules, Bicep modules, ARM modules, and then we store these code files in GitHub repos, and we will raise the PR pull request. It should be reviewed and approved, and then it will merge it. Then it will trigger the CI/CD pipeline. Then it will deploy in the cloud. So infrastructure as a code is a process of defining and managing the enterprise infrastructure, cloud infrastructures through the code. It involving treating infrastructure code in such a same way as application code and applying the same engineering practice and principle. We all know developers develop application for their clients for the project. So during the application development life cycle, they apply engineering practices and principles. This means infrastructure code should go through the well-defined software development life cycle, including version control. I am working in platform engineering team. We create Bicep module, Terraform modules to manage the enterprise infrastructures. These Bicep template, Terraform modules, everything will be kept in version control system. That means it is in the GitHub or in Azure DevOps. So we keep this ISA code, we store the infrastructure code in version control system as Git and GitHub. And collaboration. So when we keep the code, infrastructure code, ISA code in the Git or GitHub, other team members, other seniors will also collaborate. Only one particular person is not going to work on that particular ISA code, infrastructure code. Multiple team member will work on. Multiple team member will make changes. So it is a collaboration activity. So whenever a new change is made by our team members, they will raise a PR. It will go to approval, and now they seniors they will test and approve it. Then it will merge. Then it will trigger the CI/CD pipeline and deployment. So we keep the infrastructure code in version control system like Git, GitHub, and all the team members, whoever has the access in the GitHub repo, they will pull it in their local system, work in their VS Code or anti-gravity, make changes, and then they will add, commit, and push it to the GitHub repo, raise the PR. After that approval, it will be merged and trigger the CI/CD pipeline. So whatever the application code lifecycle, whatever the application code we apply the engineering practice and principle, the same practice and principle will be applied to the IC infrastructure code also. So we keep the code in version control system Git, GitHub, and all other team members will collaborate, work on the code, that is collaboration, then it will be testing. We have to validate the infrastructure code using different types of tests such as unit test, integration test, and acceptance test. So whenever you raise a PR in GitHub repo, it will perform the tests: security test, unit test, integration, acceptance test. These tests we will define in the GitHub repo, branch production rules. So the infrastructure code will undergo these tests. Once it is passed, when we raise a PR, the approver will check the code quality, perform the code linting and other automated quality checks, and code will be reviewed. Other team members will review the infrastructure changes before they are applied to the environment. And then documentation. We maintain a documentation. Here the documentation means every GitHub repo we maintain a readme.md file, that is markdown file. The readme file we specify what are the activities we will perform using the repo. So that is called documentation. So this infrastructure code will be applied in multiple environments. So we create the repo, we test in a dev environment. Once it's successful in dev environment, we will merge to QA branch. In QA we will do modification, changes, everything we will test it out. If it is successful, then we will merge into prod, that is main branch. So the infrastructure code will be the same, only the parameter will be different for each and every environment. We have a separate parameter file, dev, we have separate parameter file, the QA and prod. So using the same infrastructure code to consistently provision and manage the different environment such as development, testing, staging, and production. Depending upon the organization may be differ. Some organizations have dev, test, prod. Some will have dev, QA, prod. So it will differ based on the organizations. Here the main function is how we are going to convert the infrastructure into code. Converting infrastructure into code. One of the simplest way to implement IAC is by using the bash shell or PowerShell script. Nowadays mostly we use either PowerShell script or we will use bicep template, ARM templates or Terraform modules. These modules, this script contains the command structure to create, configure, manage and remove infrastructure resources. So these PowerShell script or bicep modules, Terraform modules can be executed periodically based on the predefined schedule, or it will be executed on the demand. Whenever the infrastructure changes are occurred, that time it will be triggered the CI/CD pipeline. So with the different configuration parameters to provision and manage different environment. So infrastructure code will be the same for all the environment. we will make the changes in the parameters. For example, the same script can be used to do provision infrastructure in the development, dev, staging, and prod by passing the environment specific configuration value, that is parameters. So each and every environment here we have a separate parameter files. So the parameter will be environment specific. The next is desired state and resource management. In IIC, we generally define what the infrastructure should look like rather than explicitly specifying every action that need to be performed. In IIC, we are not going to say first you have to create this one and then this one and then this one. Not like that. We are going to define the infrastructures in code. That means we are going to define how the infrastructure will look like. How many VMs, how many VNet, how many storage account, what is the security policies, like that. For example, this infrastructure code, the configuration may define that which machine should exist with a specific VM size, a database should exist with a particular configuration, a network should consist of a specific subnet, a particular number of resources should be available. So we define everything in the configuration files. The ISA tool compare the desired state defined in the code with the current state of the environment and determine the appropriate action. So we define the infrastructure in the code. The IIC tool will check desired state in the code and the current state in the environment and then decide what to do. Whether we want to create a new resource or modify the existing resource or ignore the resources. So based on the comparison, the IIC tool will do the comparison. It will check what is specified in the code files. What is the desired state? Then it will check the current status in the environment. Then it will compare it and then decide it. How many resources, create the resource that do not exist. If no resource exists, it will create it. Update the resource whose configuration has changed. If any resources have different configuration compared to the what is defined in the code, it will change it will make changes. That is update. It will delete the resources that are no longer part of the desired configuration. It will delete the resources or it will ignore it, make no changes when the current infrastructure already matches the desired state. So whatever we define in the code, if it is available in the current infrastructure, it will make no changes. So when we run the what if analysis, it will show how many resources we need to create, 10 to create, 5 to update or modify, 300 to ignore, like that. The infrastructure code generally does not need to explicitly instruct the system whether the resource should be created, updated, or deleted. So in the infrastructure code, we are not going to define what is to be created, what is to be updated, what is to be deleted. Instead, the ISC automation tool determine the required action based on the current state of the environment and the desired configuration. The ISA tool will check the current environment and check the desired state in the code, compare it, then it will take the action. So this approach makes infrastructure management more consistent, repeatable, predictable, and easier to maintain. So when we run this infrastructure code, Terraform init, Terraform plan, Terraform apply, it will show how many resources it is going to create, how many it is going to update, yeah, how many it is going to ignore it. Clearly it will specify. Once we are fine, either we can proceed to deploy it or we can make the changes in the code and run the what if analysis, that is a dry run again. And it will, whenever you run the dry run, that is what if analysis, it will show how much resource is going to create, how many is going to update, how many it is going to ignore. Thank you. We will meet in the next class.